like immediately to hand over to Rafik Hadjria. And Rafik, if you can give us in the beginning a few details on your life, that would be great. And then let's start. You have 15 minutes.
Thanks, Marcus. Hello all. Thanks, Tobias and Nikos, for inviting me to share with you this talk. So my name is Rafik Hadjria. I'm research engineering at Safran Research Technology, mainly dealing with structural health monitoring, let's say from sensing techno algorithms and system integration. So let's say, I am part of Safran since 2016, but during the past, I have done my PhD in structural health monitoring at Arts et Métiers in France, then have applied a postdoc on electromechanical stress reversal for Safran and things like that. So my background is mainly about sensing techno algorithms to try to enable, let's say, predictive maintenance and condition-based maintenance, we say. But they focus mainly on structural part, mainly mechanics, composite structure, also metallic, dealing with trying to health assessment about lamination and corrosion and things like that. So this briefly, let's say, introduction about myself. Let's say that for this presentation, I would like to share with you, let's say, regarding Morpho dissemination context. So, and thanks again for inviting me to this workshop, we will say. So let me just now go into the deep of the presentation. So as you know, so the global MRO will grow in the future. So here you see presented just quick information about the global MRO demand. So before the COVID, however, we expect also that this, even if the expectation will be shifted within the years, but we expect also that this the global MRO demand will also grow. Regarding this part, so the engines is mainly a great part regarding the MRO. And we would like, let's say, to, as we will have a lot of, let's say, airplane and things like that. So we would like to enhance the strategy regarding the future of MRO. So let's say, as Safran is, we are OEM and we manufacture and design nacelle, landing gear, engines, and things like that. So our idea is that we would like to enhance our, let's say, knowledge and also expectation about the MRO market, and also to enhance lifecycle management of our product. So this is why we are mainly interested about structural health monitoring. And for sure, the idea is also to accelerate the integration of new sensing techno in our project, so that to prepare the future. So Morpho, so this is why the SHM concept, as you know, so the idea is that we have an onboard sensor to try to acquire data and get information about the health assessment of our structures. But for sure, so in this sensing techno, there is a part which will be integrated within the aircraft or within the vehicle. However, electronics maybe will be off-board, and the data acquisition and the analysis will be off-board. So SHM is a techno. However, the challenge is that we have a part which is mainly on-board, and also a sub-part which can be also an off-board. And these are naturalists, I would say, from the SAE International, which I belong, so I work also with industrial partners within an IRP 6461, which has been published in August 2021, about the interest of structural health monitoring for regulation and standards. And allow me to share with you just some achievement from Delta Ireland, the Delta Tech operation, where we see that there is an interest of the MRO regarding the integration of structural health monitoring system within the inspection. Here you see that there is a program between Boeing and Delta Tech operation about the integration of sensing techno for, let's say, an NDI inspections. Because the idea of Delta Tech is that they see this techno as an NDI, integrated NDI inspection. And here we see that there is some sensing techno which has been integrated within the aircraft. And we see that a guy from the maintenance which take an acquisition system to interrogate the sensor and get information about the health assessment. For sure, this is not, let's say, this only about the proof of concept, we say it's not used, let's say, by the operator, but we can consider that when a company like Delta Tech Operation take this opportunity to test such technology, we see that there is an interest to use it for as a new inspection tool, so we'd say. So and also there is the FAA and the authorities has an interest about structural health monitoring. So this is why I will say that they have drafted which we call an advisory circular 43218, and this one has been also addressed to the MSG3 the consortium to talk about the opportunity to have a health monitoring system to try to respond to the maintenance strategy. And also a new issue paper has been also drafted and presented to the MSG3 consortium to talk about the interest of having a health monitoring system to move forward, I will say, the traditional inspections that we have, and also to move forward condition-based maintenance. However, as the aeronautics is mainly conservative, it's a great challenge, I will say. But when we see that the authority has an interest about this techno, we are convinced that that we can use it in the future. I'm not talking about the actual program, but we are talking about program that will be launched maybe in 2030 or 2035. But we are preparing the future again. So this is why I will say that from Safran perspective, we are participating, I will say, to Morpho projects. So this one is funded by the Europe, and the idea of Morpho is that we would like to integrate sensing technology to get health assessment of our composite parts. Mainly the interest is about an engine parts, which we call it the fan blade. And the idea is that we are in a circular economy, where for sure the interest is that to think about a new design and trying to move forward the damage tolerance instead of the safe life design. And for sure about the performance, we would like to enhance the operation of our equipment and things like that. But what the challenge, I will say, that our idea is that when we talk about integration of the sensing techno, we believe that the sensing techno has to be taken and tackled during the life cycle management of process of an equipment, mainly from the manufacturing process to the operation, also to the recycling. So this is why in Morpho partners, so we are about 9 partners. We have Sentisite, represented by Nikos. We have a sensing provider like Physense, and also many companies based in the Europe for sure. And this project is managed by l'École nationale des arts et métiers in Paris. And we, let's say, and Safran is a part, Safran Research Technology is a part of this. And we have also an advisory board composed by the EASA, Stanford, and other researchers from the Europe also. And if I continue about Morpho, so the idea is that to enhance the life cycle monitoring of 3D woven composite part. From the manufacturing process, we are using the RTM process. And our objective is to integrate the new sensing technology within the RTM process to enhance our knowledge on it, and also to analyze the data and try then to control this process so that we will have a repeatability between our manufactured part. And during operation, we are talking for sure about structural health monitoring in the sense of health assessment and usage monitoring. Regarding the health assessment, we have an interest about diagnostic, also prognostics, and remain useful life. And we have an interest about impact events and stuff like that. So the idea is that to get knowledge about the detection of an impact based on this different sensing techno and move forward, let's say, the remain useful life. And at the end, so we would like to recycle our 3D woven composite to try to embed it within the circular economy, where the idea is that this recycling process will be used to manufacture new projects and things like that. So our proof of concept within this Morpho project, we are using what we call the foreign object damage panel. Such a panel is mainly used in the RMT to test structures regarding, let's say, impact event. And this foreign object damage panel is a substructure of fan blade. And the idea is that we have to practice and develop techno within this this proof of concept. So many sensing techno will be integrated within this within this FOD panel that we are undergoing manufacturing, and we will demonstrate the ability to develop, let's say, a sensing techno for the process monitoring and also for the SHM related to the operation. And here, just a brief talk, a brief presentation of the RTM process. We have many stage, and the idea is that we'll integrate sensing techno for the RTM process to monitor the temperature, the curing process, and things, and many physical parameters that we would like to get knowledge on them. And then in the future, we would like to control this parameter that have to get a repeatability between the manufactured part. And once this sensing a part of the sensing integration, sensing techno are okay, we would like to use the sensing techno as a part of the SHM operation part. And here it's just we are undergoing manufacturing an FOD, let's say an RTM mold, which is compliant to our design. And the idea is that to integrate sensing techno from synthesite and other and fiber optics and things like that. So to get knowledge about this this RTM process, and when okay, so we would like to use this sensor for the SHM operation. And regarding this part, let's say our SHM is concept and techno, and it is composed of many techno element. We would develop also electronics that will help us for sure to acquire data and transmit the data. And also there is a great part within this project related to data analysis based on advanced signal processing and also artificial intelligence to move forward, let's say, the condition-based maintenance. And we have mainly an interest about, let's say, the remaining useful life of our proof of concept before reaching the critical damage state. So this is mainly the concern of Morpho projects. So that's enough for me. Thank you.